Hello everyone, I'm Victoria. Today I'm going to talk about buoyancy experiment that we did in school. So here's a brief introduction to our experiment question. We all know that transporting or disposing are two important things that we do in our lives. Transporting and disposing doesn't happen on land every time. Even if it does, buoyancy is still very important and is like the main character of a story. If we don't have buoyancy, life would not be this easy. Density is also a vital key in our lives because it also has something to do with transporting and disposing. Density matters because it can decide if an item sinks or not, or how long it takes for something to sink. Now let's get into our experiment question. What's the connection between how long it takes for an object to sink in the same distance and that object's density? I believe and hope that this experiment will help us understand more about the relationship between buoyancy and density. Why? Because in my opinion, buoyancy and density are two important things in physics. So here's our hypothesis and why we think this way. For our hypothesis, we predicted that the less dense an object is, the more time it should take to sink to the bottom of the tub. By less dense, we do not mean that the object will have a density of lesser than 1. We mean that if the object has a density of greater than 1 but very close to it, it will still sink but it will take a relatively long time compared to another object a lot more denser than water. For example, if we have an object with a density of 1.1 and another object with a density of 9, then we predicted that the object with a density of 9 will sink a lot faster than the object with a density of only 1.1. In other words, if the density of an object is a lot greater than water, then it shall sink within a short amount of time compared to an object with a density that's really close to water. Now I'm going to show you a short video of our procedure. The graph presented in front of you is a graph that included the mass and volume we have used to calculate the density and the 3 trials that we have done to get the average. We have done 3 trials to try to make the results more accurate. Now let me introduce to you the stacked bar chart on this slide. In this chart we have included the density of each measured object, the time it took for them to sink to the bottom of the tub, and the name of each object we have sunken. In this graph you can see arrows and circles. Those indicated the results that are not what our hypothesis suggested. For our hypothesis, we predicted that the densest object should be taking the shortest time to sink. But if you study this graph, you will realize that the object that took the least time to sink was a $1 coin instead of the $50 coin. Our results are a bit off here, but if you are reading this chart carefully, you can see that the least dense object, which is the ruler, took the most time to sink. Then you will realize that the fourth least dense object, which is the eraser tool, took the fourth longest time to sink. Now I'm going to tell you about our conclusion. For most of the part, our hypothesis is rejected, but for ruler and eraser tool, it is supported because the least dense object would be taking the most time. In other words, if the object's density is having a small difference with the density of water, then it shall sink slower. This reasoning proved that our hypothesis is supported here. In the experiment, we have encountered some problems. For example, we have water droplets on the surface of the electronic scales that we used to measure the mass of different things. The second problem that we have faced was second delay. The instant that we started the timer and the instant that we let go of things will be different, and that will make some of the results inaccurate, since all objects sank within seconds. So this is the biggest problem that we have faced. The ways that we held the objects are also different, and that causes resistance. Maybe that's why some of the results that we have collected are not like how we predicted it, because resistance causes inaccurate time. This is the end of my presentation. Thank you everyone for your patience and time.